Hi and welcome to my video on simplifying algebra. It's going to be a review. So this should be here to prepare you for the next algebra topic you do in year 9. If you haven't met me before, my name is Mr. Manson. So I'm going to talk about a few different things and I'll just grab it. And they'll all be important, but obviously if I'm talking about a few different things, you might find some of those that you already know and you're happy with, etc, etc. So use the video well. Fast forward, rewind as you need to, take notes, etc. First of all, some really basic algebra. So remember that we use the letters, the alphabet. Sometimes we get into Greek letters as well, but we use them and we call them pronumerals, and they represent something we don't know. So that's really important. So for example, if I don't know the cost of these pie t-shirts, I might say that the cost equals X dollars. I'm calling it X. Okay, now somebody might come to me and say, well, you just bought 12 of them and it cost you $120. And then I can work out the value of X and build that formula and solve that equation to work out the value of X. That's what pronumerals are used for. They're used in mathematics to represent things that we don't know, so that we can either model what happens as we change certain variables or solve equations to work out what they actually are. So that's really important. So a couple of terms that you will have seen and played with to do with X or A or B or whatever. So first of all, I've got 3x, this is 3 times x. The missing bit here means 3 times x. If I want to represent 3 plus x, I put a plus or divide or etc. 3x is 3 times x, and of course that divide can be written like this. 3 over x is written like a decimal, means 3 divided by x. Okay? And if I have something like ab, this means a times b. There's my two pronumerals together. Now here's a couple other little tricky ones. Well, first of all, b squared. That just means b times b, not squaring this. But we might have something like ab squared, and this means a times b times b. So we end up with this expansion on this. Okay, not to be confused with ab in brackets squared, which is a squared b squared. It's an index law that you'll talk about a little bit later on. But because the brackets are there and because we know our order of operations, the squares apply to both. So you just got to be careful with how things are written and how you deal with them. But there's a bit of an overview of that. Now let's talk first of all about some simplification to do with collecting like terms. So if I draw a couple of examples up here, we'll do them over here, and then we'll talk about how we simplify them. So imagine first of all I had x plus 3y minus 2x plus 7y. Okay, now you've got to look for like terms, and when we're looking for like terms, numerically, most of the numbers will either be a constant term or they'll be a coefficient, and they don't make as big a difference. So let me just write those two things down. In fact, I'll add another term to this, plus 3. So this plus 3 is called a constant term because it's just a number. So we've got a constant term there. Whereas this 7, it's negative 2, and this 3, and the mystery 1 here, because if there's no number it means 1, they're all called coefficients. So this is the coefficient, and in fact, more accurately, and I've missed an I there, more accurately it's called the coefficient of y. The coefficient of y is 7, but there's two y terms, so the coefficient of y is 3 and 7. Now, simplifying this. When we want to simplify, we're looking for like terms. And to look for like terms, I always start with, are there any constant terms? And then I work through my algebraic terms. This is a fairly simple one. To simplify this, constant term is 3. Cross that out as I go. X, so I'll just go to my next term. X is, there's one x here, there's negative 2 x's there. We've got x and then we're taking away 2 x's. Leaves me with negative x or negative 1x. And then I've got plus 3y and plus 7y gives me plus 10y. And this is as simplified as possible because these terms cannot be put together or brought together as a group because they're all different algebraically. So there's my first example, which to make this clear, I'll call that number 1. Let's have a look at a second example. So this time we'll have a's and b's. So we've got ab minus ab squared plus 2a minus 6ab. So I just want to make this really clear. When you introduce squares, it actually means the terms are not like again. So we've got AB and we've got AB squared. AB is just A times B. AB squared is A times B. They're different terms, not like terms, cannot bring them together. So if you get something like this, I'm going to start with my ABs. Okay, the convention might say that you come to the simpler terms, but let's just do it in order. It doesn't really matter. Start with the ABs. That's a different term, that's a different term, minus 6AB. So I've got 1AB minus 6AB, so this is equal to 5AB. Then I've got negative AB squared, so I'll cross those out by the way, just to make sure I'm not confused. Negative AB squared, and that term which is not an AB squared term, so I can't simplify that, so it's just negative AB squared. And then I've got plus 2A, which is just plus 2A. And that's all my terms. And we're done. And I should make the note there that this is called a term. So you'll see that the terms are separated by minuses or pluses. So there were 4 terms in this particular simplification question, separated by minuses or pluses, and we look to see if we've got any like terms. That's what you've been calling them, like terms. So there's my 2 examples there. The only other thing I really want to talk to you about is expanding brackets. So I might do one example of expanding brackets and then one example where we expand the brackets and we can simplify. So we'll call this one example 3 and then I'll move sideways for the last one. So the expand brackets, we get something like say 2a minus 3b. I might do 2 examples of expanding brackets. So 2a minus 3b, if we're expanding brackets, we apply the distributive law. Okay, now you will see a lot of different mnemonics and different laws that just help you remember things. The distributive law is the only law that will hold true all the way through to the end of year 12. It's the one that will help you do the harder questions. So for sure, use these nice little rules that help you remember things, but the distributive law really helps. So for this type of question, you've probably seen something like this, where you do those 2 little lines there. The distributive law means that we just do 2 times this and 2 times that, which gives us 2 times a plus 2 times negative 3b, and that's equal to 2a, and then 2 times negative 3 is negative 6, and we've just got a b there. There's my full expansion. And the second example on this, just to make it a little bit harder, we'll say x, or let's say 3x times x squared plus 3y. Okay, so I've just got pluses here. If I apply the distributive law to this, 3x times x squared plus 3x times 3y. And 3x times x squared, well, this is a bit tricky and it involves index laws, which you may have covered, you may not have, but just as a note here, x times x squared is equal to x times x times x, which is actually a definition of a cube. So x times x squared gives us x times x times x, which is x cubed. We've still got that 3 there, so it's 3x cubed plus 3 times 3 is 9, x times y, so 9xy. There's our full expansion there. Okay, so it just disappeared to write this out, so we've got place to do one more question where there's an opportunity to simplify. So let's do this time 2 times 2x plus w minus 3w times x plus 2. Let's do this question, okay? Now the first thing I want to make a statement about is this minus. So this is, getting a bit more complex. If you get a subtraction in between brackets, you've got to be really careful. That subtraction can be attached to the 3w. It means we've got negative 3w here as the multiplier inside this bracket. And the biggest mistake people make here is that they apply that, multiply it by 2, but don't leave it as a negative. So I'm going to show you this fully, and then you've got to make sure that you're working on those mistakes. So first I expand this first bracket. 2 times 2x gives me that 4x. 2 times w gives me plus 2w. We want you to show full working, but when it comes to those really simple steps, you can go straight to this. Okay, but you'll notice I'm going to write every time, I'm not going to simplify yet. Over here I've got negative 3w times x gives me negative 3wx, wx in alphabetical order. Negative 3w times 2 gives me negative 6w. Now I've done that expansion of 2 brackets and I've got a single expression with 4 terms. I want to see if I can simplify those terms. So let's start with the 4x. There's 4x. There are no other terms that just have an x. So I've got 4 of those things, and that's all I've got. Then I've got plus 2w. That's not the same, but this is minus 6w. So 2 minus 6 gives me negative 4w, and that gets rid of that as well. And then finally I've got negative 3wx. And there's no other term like it, so I'll just leave it as negative 3wx. And that is expanded and simplified. So you've done questions where we simplify this expression, expand this bracket, and now we are expanding and simplifying. And these skills here will be the required skills for you moving forward into your topic on solving linear equations and linear functions work. All the best.